Hello my friends, it's Radical Dan here. Here today I'm going to teach you about radians and degrees. Let's start with degrees and radians of a circle. How did this all begin? Well, it started with the ancient Sumerians, who were from a part of Iraq. If we look at this, they thought that the sun moved around the earth. Of course, we know that was a big mistake, right? It's the opposite way, but they said it moved around. How many days does it take, roughly? It takes roughly 365 days. So therefore, they decided that the number of degrees in a circle would be roughly 365. When they cut the circle into 4 pieces, 365 over 4 doesn't work. So they said, well, can we make it easier? Let's do 360. There it is, 360 degrees in a circle. Therefore, when you divide the circle by 4, you get 90. They should have asked me. If they asked me, I would have made the circle 400 degrees and break it into 100 each. But nobody asked me, so we can't use this one. Okay. So, circle has 360 degrees. Very simply now, because it's 360, if I give you an angle like this at the center, and this, let's just say 120 degrees, then the arc intercepting it is also 120 degrees. They're both the same. Okay? Now, what we have is mathematicians decided, let's have another way to measure the circle instead of degrees. So they decided, let's take another circle. Here's the center, and we'll call the S arc. The S is the arc, and R is the radius. And we're going to call this angle the Greek letter theta. Okay, so we have theta equals S over R. So the formula they use is theta equals S over R, where R is the radius, this is the intercepted arc, and theta is the angle. But if you notice, you'll have to memorize this formula, okay? What I found out is that you can also do this, put it over 1, cross multiply, and you get S equals R theta. And some teachers have you memorize as standing room only. Standing room only. Yeah, one time when standing room only means that you buy a ticket and you see maybe a play and there are no chairs. You have to stand the whole time. So that happened to me when I was traveling by the train. I bought a train ticket from New York to Los Angeles and it was standing room only. So needless to say that around Texas I had to sit down on somebody's lap. Okay, so if we look at this, what they decided is if I make the arc equal to the radius and I plug it into the formula, if I make this now equal to R, then theta equals R over R, which equals 1. So that's 1 radian. That's how we define 1 radian. When R over R is the same, it's equal to 1. Now, let's take a look how we can relate the degrees to the radians. Because some people use degrees, many of the scientists use radians. So let's relate them. So the formula again is theta equals S over R. But what would the arc length be if I move it around the entire circle? If I move it around the entire circle, it's the same as the circumference. This arc becomes the circumference. And we know for the formula, circumference is 2 pi r. So instead of this arc length, I'm going to make it 2 pi r divided by r. Now what do you think happens there? These r's cancel, and I'm only left with 2 pi. But if this angle opens up all the way around the circle, the theta goes to 360 degrees because we discussed earlier is 360 degrees. Therefore, if I divide by 2, pi is equal to 180 degrees. Okay, are you following? Pi is 180 degrees. Now, we're going to do some conversions. We're going to do converting, but not any of one religion to another religion. We're going to convert from degrees to radians and radians to degrees. So, let me see if I give you 45 degrees, and I want to make it into radians. What can I do? Well, if pi equals 180, then pi over 180, they're both the same, it equals 1. And that equals the same as 180 over pi. They both equal 1. So, I can multiply 45 times 1, I still get 45. I can multiply 45 times pi over 180, and I can reduce. I can multiply 45 times 180 over pi, but that wouldn't work out because it wouldn't make sense because this is degrees and this is degrees. So the one I picked to multiply is pi over 180. And if we write it, you can see that 45 cancels into 180 4 times, and my answer is pi over 4. Or you could also write it as 1/4 pi. But please do not write 1 over 4 pi. Do not write that. This is wrong. Okay. Are you still with me out there, little Len? Okay. Now I'm going to do radians to degrees. It's a nice simple procedure. Basically, if I take, let's say pi over 3. I want to make this now into degrees. If I multiply by the same one, pi over 180, I'm going to get pi squared. I don't want pi squared. So I multiply by 180 over pi. As you can see, these pi's cancel, and I'm left with 3 into 180, 60 degrees. Or you can say, here's pi over 3, I know pi is 180. So all I have to do is put the 180 where the pi is, and I still get 60 degrees. This has been Radical Dan. I hope I was able to help.